Assignment. I've shared my screen. It talks about how to do a Lewis structure, and that's all we're going to do today. It gives you the steps for doing a Lewis structure, and then the question is actually for the central atom in each formula, draw the Lewis structure with all valence electrons shown. Make sure to minimize formal charge where applicable, and note all non-zero formal charges on the Lewis structure. Draw all resonance structures where applicable. And if you go down to the bottom, you can see there's a number of problems that are assigned 2, 6, 8, 10, and 15. And some of the problems already have answer keys here printed on the page. And then if you go all the way to the bottom, there is an answer key as well. And what you're tasked with for your problem assignment is making a video about that particular problem number that you've been assigned. And what I'd like to do is I'd like to, let's see, it looks like 1, 6, 11, and 13 already have answers up. And that the problem assignments are 2, 6, 8, 10, and 15. And so what I plan on doing is going through all of the ones that have not been assigned and working on them. So it looks like the first one I'm going to do is NH4 plus, that's number 3. And I'll stop sharing my screen now, and I will instead spotlight this page right here, and I will start doing ammonium and its Lewis structure. The process, again, that we've seen on all the homework problems this morning, where go ahead and write the number of valence electrons for each atom with our periodic table right here. Nitrogen is in group 5 or 15. That means it's going to have that number 5 valence electrons. Each hydrogen has 1 valence electron, and there are 4 hydrogens, so I will multiply that times 4. And then something we talked about this morning as well, but I want to go over it again. If there's a plus charge, that means you have to subtract 1 electron, because a plus charge means that 1 electron has been removed or lost. If I add up my valence electrons now, I get 5 plus 4 is 9, minus 1 is 8. With 8 electrons, you go ahead and put, well, typically your least electronegative atom in the center. I was talking about electronegativity before, and electronegativity trend goes from fluorine. As you go left, the electronegativity decreases. From fluorine, as you go down, electronegativity increases. So phosphorus is less electronegative than nitrogen, and phosphorus is less electronegative than sulfur. And there are exact numbers for these, and the exact numbers for most of the nonmetals are on your conversion and equation sheet. One thing to keep in mind, hydrogen is a nonmetal. I think I've been here before. And hydrogen is the least electronegative nonmetal, meaning it is never in the center. There are other reasons it's never in the center too. For example, when you're bonding, hydrogen only wants 1 bond, and that will give it access to 2 shared electrons, and its nearest noble gas is helium, which has 2 electrons. So hydrogen only wants 1 bond. And if you only want 1 bond, you can never be in the middle, because to be in the middle, you have to bond to 2 other things. Anyway, that's all. Having said that, I think I drew mine a little close there. Let's give myself some more space. Here is the Lewis structure for NH4. It has all 8 electrons as 1, 2, 3, 4 bonds. And each dash is 2 shared electrons. There's a plus charge in this, and so when we do our formal charge analysis, we will see that the formal charge on nitrogen, and again, for those people who were not here this morning, let me go ahead and do a formal charge analysis. If there are more formal charge analysis that you would like me to do, just let me know. A formal charge analysis takes the number of valence electrons as you would read it off of the periodic table, which for nitrogen is 5, and it subtracts off your number of bonds, and there are 4 bonds, and then it subtracts off the total number of unshared electrons, which for nitrogen, since there are no unshared electrons, will just be 0. And my answer here is that nitrogen has a +1 formal charge, and I show that right there with a plus in a circle. This is a complete and best Lewis structure for NH4, the ammonium ion. Does anybody have any questions about it? And that's the process for going and determining ammonium's Lewis structure. Well, let's continue. If you're looking at the assignments, it looks like pH3 is going to be next. H2O, both of those are relatively straightforward. Let's get to a more complex one now. Oh, here's a good one. Well, they're all good. How about 7? We'll start there. And 7 is CH2Cl2. For this, there's going to be 4 valence electrons for carbon, plus 1 for hydrogen times the 2 hydrogens, plus 7 for chlorine times the 2 chlorines. And I get 14, 15, 16, 17, 18, 19, 20 electrons for the Lewis structure here. Now, this with carbon and 2 hydrogens and 2 chlorines. So carbon will be your central atom. It is the least electronegative atom except for hydrogen, which can never be in the center. Put carbon in the center, surround it by all the other atoms, which one thing that's strange about this is there's actually 2 types of other atoms. So far I have 2, 4, 6, 8. I need a total of 20 electrons. According to our steps, I'm going to sprinkle the remaining valence electrons around my outside atoms. And since hydrogens don't, just as a general rule, hydrogens only ever have 1 bond, and they never have any pairs of electrons. But chlorines do, so we'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I've hit exactly 20, and everybody in here, every atom that is, has an octet that needs one. And this is the complete Lewis structure for CH2Cl2. Jump in anytime if you have any questions. Ozone's got an interesting structure. Ozone is O subscript 3. For ozone, there's going to be 6 for each oxygen times 3, or 18 electrons in the Lewis structure. There's only one way to do this. It's O-O-O. I mean, I guess technically you could do this too, but these two are structurally and functionally equivalent. I've got 2 4 electrons. I need to sprinkle my remaining electrons around. I always sprinkle on the outside atoms first. 2 4 6 8 10 12 14 16. I do have 2 more electrons, and I am going to put them on my central atom. Only ever put the total number of electrons that it says right here. I can see that my oxygen does not have an octet. So this is the part in the rules or the guidelines where you complete octets. To complete the octet on the central atom, the central oxygen, I am now going to move a pair of electrons over. And my revised Lewis structure has 8 an octet electrons, 8 and 8. All 3 of these oxygens are happy, meaning they all have octets. And this will be the first one where we have to do, I guess we did a formal charge analysis before, but this has some formal charge in it. You always do a formal charge analysis. And if you do the formal charge, and one hint that you have some formal charge is that there's an oxygen with a single bond, there's an oxygen with 2 bonds, and there's an oxygen with 3 bonds. So there's a bunch of different formal charge calculations to do. In this molecule, there's actually going to be oxygen A, oxygen B, and oxygen C. Each oxygen is different here. So let's do a formal charge analysis on oxygen A. Oxygen A, so all of them, by the way.
Professor, please, I have a question.
Yeah, go ahead, Monique.
Yeah, I'm confused. I thought I got it from the homework. How do you find how many bonds you put in on the oxygen again? No way.
So, how many bonds you put on this oxygen, or which one, or all of them?
I saw one with 4, 2, and 3. I'm sorry, 2, 1, and 3.
Yes.
The one you A, B, and C.
Ah, okay. So how do you decide how many bonds each oxygen has? Is that your question, Monique?
Yes, Professor.
Okay. So, well, according to our sort of process or guidelines, so I'll go back here. So we know we have 18 electrons in here. And our process says, well, put the least electronegative atom in the center. They're all the same, so we're going to put an O in the center. And then connect it to the other atoms. So far, so good. This is the only way that it could be. And we've got 4 electrons. And then my process says sprinkle the remaining electrons around in pairs around the outside atoms first. And so far I have 2, 4, 6, 8, 10, 12, 14, 16. I need 2 more. Both of my outside atoms have 8 or an octet already, so they don't need any more. So I put the last 2 on the center atom. And now I see that my center atom still does not have an octet. And so our process to get here is what ends up determining how many bonds they have. And when I did this Lewis structure, I actually took 2 electrons from the left oxygen. I could have taken 2 from the right oxygen. It doesn't really matter. What is important is that eventually each of these atoms has an octet. So I could do it here, and what we're going to come back to in a minute, Monique and everybody, is that when you have a choice where you put the double bond, you're going to have resonance structures. So we're going to end up doing resonance structures next, after we do formal charge. So I hope that addresses at least a little bit of your question, Monique.
Yeah, thank you, boss. I think I got it now.
Okay, good. Yeah, no. And Monique, it is a process, and everybody, it is like you're gonna think you got it, and then you're gonna see a slightly different example, and then we're gonna work through it, and then you'll get that one. And this is one of those things where you just have to do about 20 of them. Hence the reason there's 20 of them on today's recitation. So, but we will get it. Yes, and keep asking those questions.
All right, thank you, Professor.
Sure. Okay, so let's use this one, and then we'll talk about resonance in a couple minutes. So oxygen C. So the first number is always the number of valence electrons from the periodic table. These are all oxygen, so they're all going to be the same. And then we always are going to subtract.
6.
And the first thing we subtract is the number of bonds. So on oxygen A, there are 2 bonds. On oxygen B, there are 3 bonds. 1, 2, 3. And on oxygen C, there's only 1 bond. So that's the first part. And then inside this, we're adding. The next thing we're going to add is the number of unshared electrons. And a lot of things in Lewis structures are about pairs of electrons, but this is not. This is number of unshared electrons. You count each one individually. So on oxygen A, I see 1, 4. Thank you. How about on oxygen B?
2.
2.
2.
Perfect. And on oxygen C?
6.
You guys got it. Perfect. Thank you. So then there's nothing to do but add them up. So 6 minus 6 is 0. 6 minus 5 is 1 or plus 1. Either one's fine. But since, like when I work with formal charges, or if you remember oxidation numbers, oftentimes I write the plus anyway, even though I don't have to. And then for oxygen C, we get minus 1.
-1.
You got it. So now we can go back and put in our formal charges. There's nothing to put on A. There's a positive to put here and a negative to put here. And when I see this, I freak out a little bit because oxygen is a very electronegative element, and yet it has a positive on it, which is kind of weird. However, it does happen and it is correct. But you should be, or you will be once you start doing these, thinking that it's weird to see a positive on an oxygen. But you double check your numbers, and definitely that is how it is. Now, oxygen cannot have an expanded octet, right? If this was a sulfur, we would have a plus and a minus, and we would form another bond to get rid of these formal charges, because if this was a sulfur, you could have an expanded octet, and that would get rid of or minimize these 2 formal charges. But this is oxygen, and on the periodic table, oxygen, nitrogen, carbon, boron, fluorine. We've never seen neon, but if we did, it would be the same thing. These elements cannot have an expanded octet. So, to make a long story short, this is our final and best Lewis structure. And once you get your final and best Lewis structure with its formal charges, then you do resonance. And these are resonance arrows. And resonance arrows say, or resonance says, whenever you have a choice where you put the double bond, draw all options. So now I'm drawing the double bond on the other side. And now I'm putting the formal charges according to where each atom is. And in total, what I have in the red box there is your final answer, because this is your best Lewis structure. Your best Lewis structure has 2 total resonance structures. And on your third exam, when it asks a question about how many resonance structures are there, if you get O3, you'll do the work, you'll get this, and you'll say there are 2 resonance structures.